With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In the figure shown, a converging lens and a diverging lens of focal length 20 cm and minus 5 cm respectively are separated by a distance such that the parallel beam of light of intensity 100 watt per meter square incident on the converging lens coming out parallel from the diverging lens. Find the intensity of outgoing beam in watt per meter square. So if you see, it is already given that the parallel beam are coming out of the diverging lens. So when it is possible? It is possible when the light that will strike it will be directed toward the focal length, right? So let's say this is the focal length of this is 5 centimeter, right? So if you see, when the ray will be directed from here to here, so it will be directed toward this. So what will happen in between? It will get refracted and it will goes parallel. So instead of, if you see, it was directed toward the focal length, and this length was 5 centimeter, right? This length was 5 centimeter, and after the refraction it goes parallel, right? So in the question it is said that it goes parallel here. So if you see here, the light rays are not actually meeting, it was directed in this direction. So if you see here, now we want the intensity. So if you see the area of this part, right, and from the similar triangle, right. So if you see here, this length is, since it is parallel rays, so this length will be the focal length, that is 20 centimeter. Since we know that when parallel rays strikes to a converging lens, after passing through lens, it meets at a focal length, right? So it is 20 centimeter. So from the similar triangle, you can get the radius of the two, right? If I say this is capital R and this is small r, you can get the relation between them, right? So if you see, we can relate the two from the concept of the similar triangle. So if I say this is capital R, this is small r, so we will write down from the similar triangle concept, the capital R by small r is equals to, if you see the base length, it is 20 and this is 5, so it is 4. So capital R is 4 times of small r. Now if you see here, the intensity was 100 watt per meter square. So what was the power with which it strikes? So power was the intensity times area. So this was the power that strikes this diverging lens. And if I write down the intensity through the diverging lens, power will remain the same, and we will divide the area of the diverging lens. So if you see here, the intensity is given in the question, so into the area it will be this. So if you put the value of this area, so circular region, if you see, the region will be circular, right? So circular area is calculated by pi r square. So in place of a, we will write down pi r square. So if you see, this is the area, and this is the area of this, it is pi small r square. So we are just writing this, right? So it will be this. So just put the value of capital R, it is 16 r square. R and R will get cancelled out. So 16I will be the intensity now. Intensity will increase 16 times. So earlier the intensity was 100, so it will be 1600 watt per meter square. Now if you see, C is the correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.